And hello once again. This tutorial is talking about the heating system in your car. Now, this is roughly a pictorial diagram. I think that will help you understand the idea. Now, there are transverse engines going this way, and there are other engines, longitudinal engines going this way. Here to here, and the engines are going this way. How can you know? There are pulleys over here. These are the belts of the pulleys. This could be the compressor, the water pump, power steering pulley. All these things are on one side. Therefore, you know it's referred to as a transverse engine, front wheel drive. If you see all these on this side, meaning the pulleys for power steering pump, compressor, alternator, if you see all of them here, it is rear wheel drive, where the back wheels do all the work. So therefore, from this picture, we see this is front wheel. Why? Because all the pulleys are here. See the belts over here. Another thing, as you can see from here, these have fans. These have two fans, small fans. That tells you right away one thing. Number one, there is no connection actually from here to the fans. In a rear-wheel drive or longitudinal engine over here, there would be a shaft and there would be a connection from here, from the water pump, to the fan, a mechanical fan. This tells you right away when you lift up your hood and you look under the hood and you see pulleys over here, and you see two fans over here like Honda, like Toyota, like all of these front-wheel drive vehicles. One thing has to come to your mind. This is electrical. And that's why we have this illuminated, this computer illuminated in this diagram. So therefore, there are mechanical fans, there are electrical fans. Again, the transverse type, the pulleys are here, no connection from here to here. Therefore, these must be electrical. And you will see connectors on the back of these radiators signifying that these are electrical. That's how you would know. The mechanical will have one big fan on the shroud, and it will be connected right to the water pump from here to here, going this way. This is going this way. So, number one, we have a heating system, coolant. As you can see, these are listed parts description, so to say. Now, we know coolant plays a major role, obviously, in the heating system. Now, at some degrees, water will freeze. At some degrees, water will start to boil. At 32 degrees, as you know, water turns into, it freezes to ice. At 212 degrees, water will boil. This is taken a level higher than that. With antifreeze, coolant, the temperature is raised to 235 degrees approximately. Why? Because of the higher temperatures and the pressure. Let's go part by part. We see our upper radiator hose over here. This is a hose. And how do I know it's upper radiator? Because it's going to the top of the radiator. So every car will have this. We have a bottom, a lower radiator going from the radiator, back to the engine. And it's on the bottom of it. So lower and upper. Now, we just said this is a pressurized system, meaning if you look at the cap, at the radiator cap over here in this example, just a pictorial, could be over here, or it could be on this side, doesn't matter. But there will be some pressure listed, labeled on that pressure cap, on the radiator cap. And usually around 15 psi. So if you look at this, first thing you open up your hood, you will see fans turning electrically from him. Number two, you will see the radiator cap say 15 psi. That means we increase the pressure of the coolant. That increases the pressure and increases the temperatures. We want it to get hotter. Now, when this happens, this temperature increases, the coolant expands in here. It expands so much that we have to dump it, so to say, into a reservoir, a recovery tank. That's what this comes into. And not to make things too complicated, but then there is a vacuum created after this goes down, the temperature goes down, and this coolant has to go back to here. But for the most important part is there's coolant flowing. The direction of it, as you can see in the pictorial, these are cylinders. Let's say 3 cylinders here, 3 cylinders here. There are water jackets throughout these cylinders where the coolant absorbs the heat in the engine. Now, we have to get rid of that heat. Otherwise, obviously, the engine will overheat. But we can also use that to our advantage, the heat. How do we use it to our advantage? We warm ourselves up in the car when we need heat. So therefore, let's understand a couple of things here from this pictorial. And I use the pictorial because I think it's easier to understand. Certain things you can't see under the hood. You have to see from pictorials, from books. Therefore, the cylinder is cold when you first start it up. The engine is first cold. There's something called a thermostat. This is a thermostat right here by the hose. This is the hose. This is the thermostat over here. This thermostat, think of it as a control valve, opens at some temperature. Starts to open at 110, 120, and it doesn't get fully open until maybe degrees afterwards, maybe 150, 160, depends on your engine. But it doesn't open in one shot. It takes time for it. The hotter the coolant, the more it'll open. So let's understand how everything is working together. We have 2 paths over here. We have cylinders over here. We have a heat. We're trying to get rid of this heat to protect the engine. So on a cold engine, everything is cold. What happens? A thermostat, the control valve, is in the closed state. Why? Because we want to trap the heat inside the engine. We want it to get hot. Since it is hot, it's getting hot. What are we going to do? We have 2 hoses over here. There's inlet hose and outlet hose going to something called a heater core. That's a miniature radiator. And what do you think that goes to? That goes to the vents in your car. So we can use this heat from the coolant that's heated and use it for ourselves to heat up the car, the passenger and the driver. So coolant will flow here to the heater core, out the heater core, back into here, into the engine. But this is cold. Until it's trapped, let's say, because the thermostat, the control valve is closed, it will allow it to heat up. Therefore, we should get, if you put the control on, at first obviously it's cold. But eventually, guess what? It gets hot. As long as you have the water pump circulating the coolant. If this doesn't work, if the water pump pumps the coolant throughout the system, if it doesn't work, then forget it. You won't get heat. This is an integral part of the system. Obviously, just like a compressor is in air conditioning. This has to pump that coolant to the radiator or the heater core, also to this radiator, to get rid of the heat, and this is giving heat. Now, a couple of things. So we just said now there's the heater core. So when we want heat, we turn on the heater control, and we get heat coming from the engine. The thermostat is in a closed position. The thermostat eventually is going to open. Let's say 110 degrees, 120 degrees, it will open. What will that do? Now remember we just said the coolant that's in this path over here, coolant coming from here to here, this is in a closed state. Therefore, coolant will not pass through it. Once it begins to open, coolant can now flow through it. So coolant can flow through here, dump off this is called the heat exchanger, dump off the heat, come back over here to the thermostat, and the cycle has begun. So therefore, coolant will flow here and here and here throughout the whole engine with water jackets, they call it, absorbing the heat and getting rid of the heat at the cost of this thermostat. This thermostat has to open. Once it opens, you get this coolant flowing through it, and this radiator gets hot also. So when you go to see if you have heat, first thing, you want to see that the water pump is working. But also you want to see this one to make sure this is hot. And also that it's not too soft and it's not too hard, the hose. There's a clamp right here, if you can see in the picture. Make sure that clamp is not loose or not too tight. Otherwise, you could have cracks over there, over here. It's connection to the radiator. So therefore, the coolant will start to flow as this opens. Think of it as a switch. It opens, allows the current to go here, and then the current will, the coolant will go here. The coolant will go here, and since the coolant is 230 degrees, 240 degrees, whatever, it's much cooler than compared to the air in outside air. Even though the outside air, you could be in Florida, it could be 100 degrees, 260, 250 compared to 100, right? That outside air is much cooler compared to that coolant temperature. So it'll go from the warm to the cold. And that's how you get rid of the hot air or the coolant, absorbing the hot air and giving it off to the atmosphere. Now, these fans that you see over here is behind this radiator. You can't tell from this picture, but they start to be turned on by a temperature of the computer. You could have one on for the radiator, could have another one on when you put on the compressor, the condenser fan. All controlled by the computer. Which one is going to turn one on or both on at the same time? Allowing to pull in the cool air. Like we said, even though it's 100 degrees compared to 250, it's cooler, right? And venting this to the atmosphere. And if you stand in front of the car and you open up the hood, guess what? You're going to feel that hot air. Where is that coming from? This one over here, the radiator. So a couple of things. First of all, water pump has to work. Thermostat has to be in the closed condition when you start a cold engine. Eventually, it has to open. Not open at one shot, open over an interval. As long as it gets hotter and hotter, the coolant, it will open more and more and more and allow the coolant to flow, and eventually it'll flow through here to the radiator, and that's what you want. A second thing is, while this is happening, we still could get heat through our vents by this heating system, which is trapped in here. Even though this is in a closed position, which we want it to be, that heat is going to be absorbed in here and allow it to go. See the hose? This hose come out the other hose like this. As long as the water pump is doing his job. Okay? That's that thing. So, therefore, all of these things work together. And if you want to see the picture of it, of the coolant, let's say the coolant is in this position. We have a cross flow radiator, as you see, going from here to here. The coolant, that's going from here, from the radiator to here, and the water pump is working. Right? These are water jackets and all these in the cylinders. This water pump over here will allow this coolant to flow. There's a thermostat in here that you cannot see, which will open and allow this to go out. And the coolant will go out through here, back to the cycle all over again. The cycle repeats itself. As we said before, what happens until that happens? You see, these are the thicker hoses. The thicker hoses go to always the radiator. The thinner ones go to the heater core. So the heater core allows, it's a miniature radiator, allow the passenger inside the car to have that heat that we need in wintertime, as you can see. So therefore, a lot of things depend on The radiator, the fans have to work. If the fans do not work, you will overheat. So I hope this was informative. And the first thing, if you don't have heat, you have to make sure the water pump is working. You have to make sure that if that thermostat stays open instead of in a closed position, the air will not heat up that quickly. It will be colder. So a lot of the time the thermostat, a lot of the times the water pump, as you know, belts, hoses always have to be checked. Hoses sometimes could be cracked. But guess what? If these two don't work, go to the computer. Like we made so many videos about them. That computer gives the control, the commands for these ones to go on by giving them a ground that we went over so many times. Of course, you need the coolant level to be proper. Now, if you see, let's say that there's low on coolant, of course you're gonna open up when it's cold and you're gonna put more. But if you see a leak around here, let's say, and you believe it's coolant, obviously, right? What are you going to do? You're going to put more. But if you're going to pour more coolant, guess what? It's a pressurized system. It's just going to leak out. And remember, in these type of cars today, there are sensors and modules all over these locations. When it leaks out, you could do damage to other components, especially connectors and electrical sensors and modules. You have to be careful. Okay. First thing is you have to pressurize the system to 15 psi, whatever it is, to see where the leak is, to make sure. There's no reason if you see a leak, let's say it comes from here. Many times customers come and they say, "Oh, there's a leak here," and they think it's a radiator, but it could come from here also. If you detach this or take this radiator hose out when this was open thermostat and it was hot, guess what? You're going to have coolant all over here. You're going to think it's the radiator. It's not. There might be a crack here. Or maybe the person took out the hose, the upper radiator hose, where the coolant was, and he never cleaned it, and it leaked onto here. So you can't always analyze and say it's the radiator wherever you see the coolant leak. That's why it's better to pressurize the system. Always pressurize it. Then you'll see properly where the leak is. Always check the hoses, obviously, like I just said before. But thermostat also, these don't turn, go to here. If you don't see heat over here, maybe the thermostat is stuck open. Maybe the water pump is not working. Anyway, please go to my channel, Joe Electronic Schematics for Auto, and also my other one, Automotive Electronic Schematics by Joseph, where you'll see videos, and especially a video that I said, if there's a battery over here, there's a battery over here, wherever that battery is. If it's cold outside, let's say January right now, increase the current. You're cranking, cold cranking amps. Instead of 600 if you have, increase it to 800, 850, 900. It'll cost you more at the end, but every customer I've had never had a problem. Even if they leave it 2 weeks in the cold, they start the car will crank. Why? Because the battery, just not the voltage, is important. What's important is the current. The current is important, that it can deliver that current in the cold weather. Remember, when you have a car, that engine is new, everything is new. Over time, over years, that engine is not the same as it was 5 years ago, 6 years ago. There's more resistance on the battery. That battery has to overcome that resistance, more current. So always increase your current rating when you have to change the battery. For whatever reason, if it's a weak battery and I'll see 600 cold cranking amps, I'll buy one with 800, with 1,000, even though it'll be more. If there's a problem that doesn't fit, or sometimes you have the bracket on top that it doesn't fit because you change it to a bigger battery, there are brackets that you could buy, probably online, that they extend, and you can use those, or you could put a strap around it. But that battery cannot move. You cannot pass inspection if your battery vibrates. It has to be permanent. That's why you see a bracket on it. Imagine going up a hill and that battery vibrating. No, you have to have a bracket holding it, supporting it, that it does not move. Like I said, they have adjustable ones. So if that's a problem and you can change your battery and you think, okay, it's a different height or things like that, there are adjustable brackets. Anyway, I hope this was helpful. Please go to my channel to see other videos of how to test a battery with either resistance or current, load test, and also how to measure relays. So many questions about the relays. Do not take out the relay. Put a relay, leave it in, take a piece of wire and measure that relay in circuit. Don't take out and don't jump it. Go for that video. Thanks for watching.